we've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this. This is 3I Atlas. You know how the last time we talked about it, it went behind the sun, then it got brighter, then it got bluer, then it started to go faster, non-gravitational acceleration? Well, guess what? We just got new images of it, and to add some more strangeness to the 3I Atlas saga, because, like, I don't want to overhype this.
Well, it looks like China has officially stepped into the spotlight of space exploration once again, because its Tianwen-1 Mars orbiter has done something pretty remarkable. It managed to capture rare images of the interstellar comet 3I/Atlas during its close approach. And these images have suddenly brought this mysterious visitor back into global scientific focus. This time, the attention isn't based on wild theories or internet rumors, but on actual, verified observations that seem to challenge a bunch of what scientists thought they understood about this object. After its closest approach to the sun, new photos of Comet Atlas revealed something puzzling. Instead of showing the large, dramatic tail everyone expected, the images displayed a compact nucleus with almost no massive dust stream behind it. Precision tracking also found that Atlas wasn't behaving quite like a normal comet. It showed lateral movement and non-gravitational acceleration, both of which don't really fit with standard cometary physics. So naturally, the discovery has stirred up a mix of excitement, confusion, and curiosity among astronomers. But behind these scientific updates, something else has been unfolding, and it's a little more political. In the middle of all this, there have been sudden administrative changes in major space agencies, strange public announcements, and growing speculation about whether political motives might be influencing the timing of what data gets released to the public. Then came November 4th, 2025, a date that quickly got people talking. That's when President Donald Trump made an unexpected announcement on his social platform, Truth Social. He said that Sean Duffy, who was then NASA's administrator, would be replaced by billionaire Jared Isaacman. The news itself was already surprising, but what really caught attention was the timing. The decision came right after a controversial exchange on Twitter involving Kim Kardashian. Some called it a coincidence, but others in the scientific community couldn't help wondering if the leadership shakeup had something to do with the ongoing Atlas observations. While the United States waited out a government shutdown, NASA's best images of Atlas, taken by the high-resolution HiRISE camera, remained unreleased. Then something unexpected happened. China's National Space Administration, CNSA, broke its silence. On October 3rd, 2025, China's Tianwen-1 orbiter had captured Atlas from 28.96 million kilometers away, and now those images were being released to the world. These weren't some casual telescope snapshots. They were high-quality scientific data from one of the world's most advanced space probes. The Tianwen-1 orbiter, which has been circling Mars since early 2021, used its HiRISE camera, a powerful instrument with a 38.7 centimeter primary mirror. Although it doesn't quite match NASA's 50 centimeter HiRISE camera, it's still incredibly capable. And the results were stunning. The Chinese images showed Atlas's bright nucleus surrounded by a coma several thousand kilometers wide, giving scientists a clearer view of its structure than ever before. Even more impressively, Chinese researchers went a step further. They put together an animation showing Atlas moving through the Martian sky based on a series of 30-second exposure shots. For the first time, the world could literally watch this interstellar traveler moving in real time. Then, as if things weren't dramatic enough, an American congresswoman decided to go public with what she knew. She posted on her social media that she had spoken with NASA about Atlas and confirmed that once the government reopened, NASA would release both the images and scientific data. She also added that Harvard astrophysicist Dr. Avi Loeb's earlier analysis, which mentioned strange features in the comet's tail, had been correct, and that NASA had noticed those same anomalies. She ended her post on a hopeful note, saying that with modern technology, scientists would likely track many more interstellar objects like Atlas in the near future. Her statement sent ripples through the space community for several reasons. First, it officially confirmed that NASA had observed the same oddities Avi Loeb had been talking about. Second, it hinted that there might be many more unusual interstellar visitors out there than the public realizes. And third, it quietly admitted that key data was being withheld, not for scientific reasons, but because of bureaucratic red tape. Now, when researchers compared their latest datasets and models, two big things stood out about Atlas's movement. The first was an unexpected sideways shift. The comet had moved laterally, left and right, in a way that didn't match predictions. But strangely, it hadn't moved much vertically, suggesting its trajectory was being affected by some kind of specific and controlled force, rather than random gravitational tugging. The second was the presence of ongoing non-gravitational acceleration. Basically, something kept pushing Atlas slightly off its expected path, even after accounting for the sun's gravity. And although the acceleration had dropped to about 1/3 of what it was earlier, it was still statistically significant and still unexplained. To scientists, this meant there were extra forces acting on Atlas in ways that didn't line up with normal physics. In simpler terms, it looked like something was pushing or guiding it laterally and radially, but not vertically. This brings us to what some are calling the 5 billion ton paradox. Normally, when a comet accelerates in space, it's because it's venting gas or dust like a rocket effect. As ice and gas shoot out from its surface, it slightly changes its speed or direction. Based on the math, if Atlas's acceleration was really caused by that kind of outgassing, it should have lost around 13% of its total mass during its close pass to the sun. That's billions of tons of material. But that's not what the new images show. There's no massive cloud of debris trailing behind. Instead, the nucleus looks dense and compact, and the surrounding coma, that fuzzy glow around it, is relatively modest. Reducing the calculated acceleration helps a bit because it means less material would need to have been expelled. But it still doesn't solve the core mystery. Atlas is accelerating like it's losing mass, but there's no evidence of that mass loss. Then there's the issue of composition, which only deepens the mystery. Spectroscopic readings show that Atlas is mostly nickel, with almost no iron, an extremely unusual ratio. Even stranger, it has an unusually high carbon monoxide to water ratio, along with traces of exotic compounds that could even be byproducts of industrial processes, like nickel tetracarbonyl. That's not what anyone expects from a natural object that supposedly came from the cold, ancient outskirts of another star system. Normally, such comets are rich in ice, dust, and rock, not in rare metallic and chemical combinations. And the optical measurements, which analyze how light scatters off the comet's surface, showed strong negative polarization, something that usually means the surface particles are large, porous, and structurally complex. That's the complete opposite of what's observed in ordinary comets from our solar system. At this point, scientists have narrowed things down to 3 possible explanations. The first one is that Atlas is simply a very unusual natural comet, one that behaves differently because of its unique composition or structure. Maybe it ejects particles in a more directed way instead of evenly, or maybe its gases escape at higher velocities than usual. These tweaks could, in theory, explain the odd motion without invoking anything artificial. The second hypothesis is that there might be non-thermal mechanisms at play, meaning internal forces or even engine-like processes that propel material faster than natural heating could. This would allow for the observed acceleration without requiring such massive amounts of gas or dust to be expelled. And the third, far more controversial idea is that Atlas might be an artificial probe or artifact, something created intentionally rather than naturally. This theory, while extremely unlikely, can't be completely dismissed yet. It would need clear evidence of artificial emissions, geometric structures, or industrial materials to be taken seriously. But until those possibilities are fully ruled out, it remains on the table as a scientific curiosity. Another oddity is Atlas's retrograde trajectory. It's moving in the opposite direction to the planet's normal orbits, yet it's aligned almost perfectly with the ecliptic plane, the flat disk where most planets travel. That's statistically almost impossible for an interstellar object, which should be arriving from random angles and directions. Then there's something called an anti-tail, a phenomenon where the dust and gas stream actually points toward the sun instead of away from it. Observers noted that Atlas appeared to be forming this kind of beam directly at the sun, which is the exact opposite of what conventional cometary physics says should happen. Normally, solar radiation pushes debris backward, forming the bright tails we're used to seeing. So if Atlas really has an anti-tail, that's one more sign that its behavior is anything but ordinary. All these clues, the unexplained motion, the strange chemistry, the missing tail, and the anti-tail, add up to a mystery that's hard to categorize. Some scientists are calling Atlas a new type of interstellar comet, while others think it could be evidence of complex natural mechanisms we haven't yet modeled correctly. And then there are a few who quietly wonder if it might even be something not entirely natural. Either way, it's clear that this object has sparked a kind of space race for answers. Because while the US continues to sort out its political reshuffling and waits to release NASA's high-resolution data, China has already stepped forward and shown what its Mars orbiter can do. The Tianwen mission has now proven that it's not just capable of planetary science, but also of deep space observation at a world-class level. Comet 3 I/Atlas has turned into one of those puzzles that just keeps getting more interesting the more you look at it. It's not just another frozen ball of ice flying through space. The deeper astronomers dig, the stranger it seems. Like Atlas's size and speed are both way above what's considered normal for a comet. Its nucleus is much larger than average, and it's moving with unusually high velocity. That mix alone is rare because big, heavy comets usually don't travel this fast unless they're made of something stronger and denser than the usual blend of ice and dust. So right away, that tells scientists there might be something different about the material holding it together. Maybe something more resistant or compact than typical cometary stuff. Then there's the way Atlas moves around the solar system. It didn't just swing past randomly. It actually performed what some astronomers are calling a synchronized series of planetary flybys, almost like it was following a deliberate path that took it near major planets in a carefully timed pattern. Because of that, observing it directly from Earth became much harder. Each time it got close enough for sensitive instruments to gather detailed data, its trajectory shifted again, narrowing that observation window. That kind of orbital dance, as a few experts describe it, almost felt too coordinated to be a coincidence. Things get even stranger when you look at what Atlas is made of. Its spectral readings, basically its chemical fingerprint, show something very unusual. There's a dominance of nickel, almost no iron at all, and a high ratio of carbon monoxide to water vapor. That mix doesn't match any known type of comet formed in our part of the universe. It points to an origin in some completely different kind of astrophysical environment, maybe from a system with chemistry unlike anything we've studied so far. Optical data adds another twist. Measurements of how light scatters off Atlas show extreme negative polarization, stronger than what's ever been recorded for cometary dust. That means the particles around it are probably larger, highly porous, and structurally complex. Nothing like the fine, simple grains typical in our local comets. Put all that together, and you start to see why scientists keep saying, this one is out of the ordinary in almost every possible way. And then there's the question of where it came from. When researchers traced Atlas's trajectory backward, it seemed to point roughly toward the same region of the sky where the famous WOW radio signal was detected back in 1977. That coincidence doesn't prove anything, of course, but it has definitely revived a bunch of old debates about possible connections or shared cosmic routes. Even its brightness has been unpredictable. Normally, a comet's glow follows a steady thermal curve. It brightens as it nears the sun and dims as it moves away. But Atlas suddenly flared with strong green emissions, changing color and brightness in ways that didn't fit any known pattern. Those random spikes made it look as though something inside was reacting to solar energy in an unexpected way. And while early models suggested its acceleration could be caused by gas being ejected, the classic rocket effect that pushes comets off course, the images taken later didn't show nearly enough debris to justify that idea. In fact, it didn't show any of the massive dust plumes you'd expect. That's what scientists are calling a fundamental paradox: acceleration without the visible signs of mass loss that should cause it. To make things even harder to explain, Atlas seems to release its gas and dust symmetrically. Even though it shows signs of outgassing, it doesn't display the recoil motion predicted by Newton's third law. In simple terms, it's venting material, but not jerking in the opposite direction. That could mean its jets are incredibly well distributed, or its inner structure behaves in some extraordinary, balanced way we don't yet understand. Now all eyes are on December 2025, when astronomers will get their best chance to figure out what's really happening. A coordinated observation campaign between late November and January will bring together data from multiple observatories, with the critical point on December 19th.